Hello everyone and welcome back to the fourth episode of our TV remote control series. In the previous episode, we looked at the remote control itself and some of the markings on this housing. But today we are going inside. This is the circuit board, the PCB of our Philips TV remote control. And when I first looked at it, I thought it's just a green board with some components on it. But after looking more carefully, I found that there are actually many different markings, codes, materials, and design details on this small board. So, in this episode, we are going to investigate them. First, I'll briefly explain what this PCB is and what we are looking at. Then we'll examine the brown side and decoded its markings as far as we can. After that, we'll turn it over and look at the green side. And finally, we'll compare some of these markings with the markings we found on the remote housing. And there are actually some very interesting connections. So let's start with the PCB itself. PCB stands for Printed Circuit Board. In simple terms, a PCB has two main jobs. First, it mechanically supports and positions the electronic components, and second, it electrically connects those components together. Instead of connecting every component with separate wires, the PCB uses conductive paths called traces. You can see these paths running across the green side of our board. They are not random lines. They are part of the electrical circuit and provide the connections between different parts of the remote. The board itself is rigid and has a composite insulating substrate. Based on the physical and visual characteristics of this board, its substrate appears to be CEM_1 type. However, without manufacturer documentation or material analysis, we cannot confirm the exact substrate type with certainty. The green layer covering the board is called the solder mark. It protects the copper underneath and electrically isolates areas that should not normally be connected. It also helps control where solder can contact the PCB during manufacturing. And one more interesting thing about this board is that its electrical copper circuitry is concentrated on one side. So this is a single-sided PCB. That doesn't mean absolutely nothing can exist on the other side. It means that the conductive circuit pattern is on one side of the board. And now that we know what we are looking at, let's turn the board over and start decoding the markings. Let's start with the brown side. There are many markings here, and not all of them have the same purpose. This is important because when you see a number printed on PCB, you shouldn't automatically assume it is a model number or date. Some markings are design identifiers, some can be part numbers, some can be dates, and some may be internal manufacturing or traceability codes. The problem is that manufacturers don't always publish a document explaining very internal code. So, through this investigation, I separate what we can establish from what we can only interpret. Let's start with one of the easiest ones. Here we can see P/N, which started with 114. P/N is a common abbreviation for part number. So this number is a part number identifier. That's relatively clear. What we cannot determine from that number alone is exactly what level of the product it identifies. It could refer to the PCB, as you can see here, an assembly, the remote, or another internal part. So we know what type of information it is, but not necessarily what exact object Philips assigned this number to. Next, we have VER 1.1. VER is commonly short for version, so this is very likely a version or version identifier. It could refer to a hardware revision, as you can see here, PCB artwork revision, engineering revision, or another internal version. But the important point is that 1.1 indicates a version or revision of some kind. Now we have the number which started with 2015-10-8. This looks strongly like a date written in the format year, month, and day. So 2015-10-8 would be October 8, 2015. But here's where we need to be careful. We don't know exactly what happened on that date. It could be a design date, engineering date, production related date, release date, or something else. So I'll say it is a date format code, but its exact purpose is unknown. Now we have another number, WG180. This one is much more difficult. It's clearly an international identification marking, but I couldn't find reliable documentation explaining exactly what WG180 represents on this PCB. It could be related to a project, supplier, factory, material, or another internal manufacturing system. But those are only possibilities. So for now, WG180 means unknown. And this is an important part of the investigation. Sometimes the correct answer isn't this means X. Sometimes the correct answer is we don't have enough evidence yet. Now we come to one of the most interesting markings on this site, which started with HOF. I searched for other Philips remote controls containing the same type of identifier, and I found Philips remote controls identified with codes such as HOF-47I-HO47AD and another which starts same but finished with 6 to 7. One of these identifiers is also associated with a Philips part number in remote control databases and listings. So we have some evidence that HOF-47E is associated with a family or design of Philips remote controls, but we still don't have a Philips engineering document telling us exactly that HOF-47E, HO-47AD means. So I don't want to invent an explanation. The safest conclusion is HOF-47E appears to be an internal identifier associated with a Philips remote control design or family, but the exact meaning of its individual section remains unknown. There are also several other markings on this site. For example, which started with L16214. At first, it's tempting to say that the circled L means lead free, but I couldn't find reliable evidence proving that this particular symbol on this particular PCB is a standardized lead-free symbol. So I won't claim that. The meaning of the symbol and the number sequence remains unknown. It could potentially be related to production, traceability, a lot, work order, material identification, or another internal system. But again, we don't know. We also have D/4. This could possibly be related to manufacturing, inspection, testing, or production traceability. But we don't have evidence proving that D means a day shift or that 4 means a particular production line or inspection station. So again, possible manufacturing or traceability marking, exact meaning unknown. And here we have 2016-0801. This one again looks like a date. It corresponds to August 1st, 2016. But just like the other date, we don't know exactly what even it represents. It could be related to manufacturing, inspection, engineering, production, release, or another internal process. So date format marking, exact purpose, unknown. Now let's look at the black markings. We have codes start with 4468 and H752. they look visually different from some of the white markings. That suggests they may have been produced using a different marking process or belong to another identification system. But we should not assume that the color tells us exactly when or at which manufacturing stage they are printed. For example, we might be tempted to say that one is a pick and place matching code or particular factory code, but we don't have evidence for that. So, 4468 appears to be an internal manufacturing or traceability code, but the exact meaning is unknown, and H752 is also currently unknown. But this second one gives us an interesting clue because I found H752 somewhere else, and we'll come back to that at the end. Now let's turn the board over, and immediately we can see that this side is much more interesting. We have the green solder mask, copper traces, the electronic components, and all the keyboard contact position. And we also have another group of markings. The most obvious ones are the many K numbers. For example, K46, K47, K48, and many others. What are the K numbers? Because these K numbers are positioned around the individual keyboard contact locations, they appear to be reference or design identifiers for the individual key contact position. In other words, they help engineers identify different positions in the PCB design. They can be useful during design, documentation, testing, troubleshooting, and servicing. But I want to make one small clarification. I don't want to claim that the letter K universally means key or switch. Reference designer conventions can vary between manufacturers and design systems. What we can actually see on this PCB is that the K-numbered markings correspond closely with the keyboard contact positions, and that physical evidence makes this interpretation reasonable. But then I noticed something interesting. If the board has K numbers going from K1 to K50, where are K4, K24, and K25? They are missing, and this could be a question you might have too. Why would a PCB have K1 through K50 but skip three numbers? There are several possible explanations. One possibility is that this PCB design was created as a common platform for different remote control variants. Maybe another version of the remote had additional keys or contact positions. Another possibility is that some positions were removed during development or a later design revision, while the existing reference numbers were not numbered. And the organization of the keyboard matrix could also be related to how the key positions were assigned in the original design. But here's the important part. We don't know which explanation is correct for this particular PCB. Without the original schematic, engineering documentation, or another matching flips remote, we can't prove why key 4, K4, K24, and K25 are missing. So for now, they remain a small mystery. We can also see STX, I hope you can see, STX0510 and CAV6. Both clearly appear to be intentional PCB markings, but I couldn't find reliable public documentation that explain exactly what they mean on this PCB. So, STX0510 is unknown, CAV6 unknown, and then we have 47E. Again, we can clearly see the marking, but don't have enough evidence to decode it. Interestingly, the same characters 47E appear inside the large identifier HOF-47I-HO47AD. on the brown side. That makes the marking interesting, but it still doesn't tell us exactly what 47E means. And finally, we have 0808. I checked the board closely, and this is what I can actually see. But again, without documentation, we don't know whether it represents a date, production information, inspection information, or something else. So 0808 is unknown. And now let's connect this PCB to something we discovered earlier. Remember this code, H7552, where we see it. Let me know. Yeah, here. As you can see, it's printed on the PCB. Yeah, here, as you can see. It printed on the PCB. Now let's look at the rear housing of the same remote. We found the code which started HOF. Okay, look carefully. Both contain H752. That doesn't prove exactly what H752 means, but it is a very interesting connection. It suggests that H752 may be some kind of shared product, design, manufacturing, supplier, or traceability identifier. We simply don't have enough documentation to know which one. And there's one more interesting connection between the markings on this PCB and the plastic house. On the front cover, we have, let me show you. The front cover, we have HOF-47I 1.1, but on the rear cover and the battery cover, we find that H47E 1.2. So we have the same HOF-47E identifier appearing on several different parts of the remote, and we have already seen HOF-47E on the PCB itself. This strongly suggests that these markings are not random. They appear to connect different parts of the same product or product family. But what exactly do 1.1 and 1.2 mean? Are they revision, mold version, production or tooling codes? We don't have enough documentation to say for certain. And that's important. We can observe the pattern, but we shouldn't invent an explanation for it. And there's another connection that I find even more interesting. Remember, the specific marking 2016-0801, it appears to represent August 1st, 2016. Now look at the rear cover, 60-09-01. If this follows the year, month, day format, it would correspond to September 1st, 2060. So we potentially have August 1st, 2060 on the PCB and September 1st, 2060 on the housing. That's exactly 1 month apart. Is that a coincidence? Could this represent different stages of production? Could one be engineering or inspection date while the other represent manufacturing or assembly? We don't know. And I think that's actually the most interesting part because without the manufacturer's documentation, we can't turn this clue into facts. We can only follow the evidence. And that's where I stop our investigation of the PCB markings. We were able to identify some markings with relatively high confidence. We found part numbers, version information, date formatted codes, and probably PCB design or reference identifiers. But we also found many codes whose exact meaning remains unknown. And if you know what any of these markings mean, especially WG180 STX05 V6 47E0808 H752 or the missing K4, K24 and K25, please let me know in the comments. If you have experience with the PCB manufacturing, electronics engineering, or Philips remote controls, your information could help us solve some of these little mysteries. But the markings are not the only interesting thing on this board. Because next we are going to look at this black printed context. What exactly are they made from? What are they black? Why do they have these unusual shapes? And how can simply pressing a rubber button on top of them actually tell them remote control which button we pressed? That's what we'll investigate in the next episode. Thanks for watching, and I'll see you in the next one. Bye!